In this video, we're going to look at the sine and cosine rule. Now, we use the trig ratios for right angle triangles. Let's say you want to find a missing side or a missing angle, you would use the trig ratios and also Pythagoras theorem. But when it comes to non-right angle triangles, we use the sine or the cosine rule. So before we learn how to use the sine or the cosine rule, we must know how to label a non-right angle triangle. Now you can see that I have a non-right angle triangle here, which is triangle ABC. This capital A at the vertex here will represent the magnitude of this angle in here. Likewise, capital B and capital C will represent the magnitudes of these angles here. So we established that capital letters represents the magnitude of an angle. Now, the common letters are going to represent the length of the side. So if we have capital A up here, which represents the magnitude of this angle, if we draw a line from capital A, it will touch this side. And we call this side BC common A. So common A will represent the length of this side, which is BC. So capital A up here, draw a line from capital A will touch this side, which we call common A. So the common A representing the length of the side and the capital letter representing the magnitude of the angle. So likewise, if we were to draw a line from angle B, it will touch this side. And this side AC will be the side opposite angle B. Therefore, we call this side common B. So again, common B represents the length of the side AC, while capital B represents the magnitude of the angle at B. And if we draw a line from angle C, it will touch this side. And therefore, this side AB will be called common C. So common C represents the length of the side AB, while this capital C represents the magnitude of the angle C. And now this is how we label a non-right angle triangle. So now let's look at the formulas for the cosine rule. So we have a squared is equal to b squared plus c squared, take away 2bc cosine capital A. Now notice if we start with common A and common A represents the length of a side, we end with capital A, which represents the magnitude of an angle. So notice common A is out here, but it's not on this side of the equal sign. We have the other two sides, which are B and C. We also have B and C here. So you start with common A, you end with capital A, and within here, common A is not repeated, but the other two sides, B and C. B and C. So that means if you started with common B, let's say B squared is equal to, the other two sides would be A and C. So you would have A squared plus C squared, take away 2AC cosine, and since you start with B, you will end with capital B. So you have angle B here, cosine of angle B. And likewise, if you start with side C, so that's common C squared, that'll be equal to the other two sides would be A and B. So you'll have A squared plus B squared, take away 2AB cosine, and since we start with common C, we will end with capital C. And that's how you use the formula for the cosine rule. So moving on to the formulas for the sine rule, we'll have common A over sine capital A is equal to common B over sine capital B, which is equal to common C over sine capital C. Now remember, the common letters represent the length of a side and the capital letters represent the magnitude of the angle. So notice if you have A on top here, you have angle A below here. If you have side B on top here, you have angle B below here. And remember, it must be sine of an angle. All right, so side C on top here and you have angle C down here. Now what does this mean? You could have A over sine capital A is equal to B over sine capital B. And we can use this to solve for either angle A or angle B, or side A or side B. Or we could have A over sine capital A is equal to C over sine capital C. And the other variation of this would be B over sine capital B is equal to C over sine capital C. So I'll just put or B over sine capital B is equal to C over sine capital C. So this is how you'll use the formulas for the sine rule. Now, let's just say I change the labeling on the triangle to triangle PQR. Then the side opposite angle P would be common P. So this common P will represent the length of the side Q to R. The side opposite angle R would be common R. And this will represent the length of the side QP, common R. And the side opposite angle Q would be common Q. And this will represent the length of the side RP, this common Q. So my three sides are P, Q, and R. So for the cosine rule, if I were to start with common P, I'll have P squared. The other two sides would be R and Q. So we're going to have R squared plus Q squared. Take away 2RQ. And since we start with P, we're going to end with P. So we're going to have cosine capital P. If we were to start with R, we'd have R squared. The other two sides would be P and Q. So we're going to have P squared plus Q squared. Take away 2PQ. And since we start with common R, we're going to have cosine capital R. Likewise, if we were to start with common Q, we'll have Q squared is equal to, the other two sides will be P and R. So we have P squared plus R squared. Take away 2PR cosine. And since we start with Q, we end with capital Q. And for the sine rule, we'll have P over sine capital P is equal to common Q over sine capital Q, which is equal to common R over sine capital R. So now let's move on to using the cosine rule and the sine rule to find a missing side or a missing angle on a non-right angle triangle. Alright, so here I have my first question using the cosine rule. So here we want to calculate the length of the side AC. Now we know when it comes to non-right angle triangles, we can use either the sine rule or the cosine rule. Now how do we know which one to use? Let's look at the situation here. The two sides that are given, the 4.2 centimeters and the 5 centimeters, we have this 45-degree angle in between those two given sides. Now that would suggest to me that we can use the cosine rule to find the missing side. And that is the pattern I look for to know to use the cosine rule. The angle is in between the two given sides. I can use the cosine rule to find the missing side. So the first thing we'll do is label this triangle. If I draw a line from angle B, it will touch this side here. So that will be side B. So I'm going to put common B here. And again, if I draw a line from angle B, it will touch this side. So this side here is common B. If I draw a line from angle C, it will touch this side. So this side here is common C. And if I draw a line from angle A, it will touch this side. So the length of this side is common A. So this 5 centimeters will be common A. This 4.2 centimeters is common C. And what we want to do is find common B. So I'll just label this common A. So again, we're going to find the length of the side AC, and AC is common B. So writing the cosine rule, starting with common B, we know we have to end with capital B. So we have B squared is equal to, the other two sides are A and C. So we have A squared plus C squared, take away 2AC cosine angle B. Let's fill in the values. So we're going to have B squared is equal to A squared, so A is 5. So that's 5 squared plus C squared, that's 4.2C. So we're going to have 4.2 squared. Take away 2 times A, and A is 5, times C, and C is 4.2. Cosine angle B, and angle B is 45 degrees. Now what I like to do is to work this entire thing out on the calculator, but I'll need to insert some brackets. So I'll have to put some brackets here on the calculator and also here on the calculator. So what I'll do is open brackets, put in this information, close brackets, take away, open brackets, put in this information, close brackets, and press equal. And that will give me what B squared is equal to. So here I have my calculator. First I'm going to make sure it's in degrees because that 45 degrees is in degrees. So the calculator must be in degrees to get the right answer. So I'm seeing this D at the top here, so we're good to go. So I'm going to open brackets. We're going to put in the 5 squared. So 5, press the x squared button to square it, plus 4.2, press the x squared button to square it. We're going to close the brackets. Then we're going to take away. Then we're going to open brackets again. And we're going to put in the 2 multiplied by the 5 multiplied by the 4.2 multiplied by the cosine. Now, see when I press cosine, it open brackets here. So I'll put in the 45 degrees and I need to close the brackets for the cosine. But remember, I still have the brackets open for this part of it, right? So I have this open bracket here still. So I need to close it off here. So what the calculator did, it opened brackets for the angle. So I have to close the brackets for the angle. And then I need to close the brackets again because this bracket here is open. So that's why on the calculator, I need to close brackets again like that. And I press equal, and I get 12.94. If you write this to 3 significant figures, we have 12.9. And seeing that I would want to approximate the final answer to 3 significant figures, I will go with up to 4 significant figures. So I'll put 12.94. So I'll write b squared is equal to 12.94. So therefore, b would be the square root of 12.94. All right, so I go on my calculator, press square root, and put in that 12.94, press equal, and now I can write this to 3 significant figures. So I have 3.59, I'll stop at the 9. After the 9 is a 7, so this 9 will go up by 1, which will push this 5 up by 1, so I'll have 3.6. So I'll have common b is equal to 3.6 centimeters. And remember, common b is the length of the side AC. So I'll have AC is equal to 3.6 centimeters. So here I have question 2 for my cosine rule, and we want to calculate the value of the angle ABC. Now we know the letter in the middle, which is B, tells us where the angle is located. So that means we want to find angle B. So that's why I have this highlighted here, that we want to find angle B. Now remember what I told you, if you're using the cosine rule to find a missing side, the angle must be in between the 2 given sides. Now here we want to find the missing angle, and to use the cosine rule to find any missing angle, we need all 3 sides. That means we need to know the lengths of all 3 sides of the non-right angle triangle. Now seeing that I want to find angle B, my cosine rule must start with common B. So first let's label the sides of this non-right angle triangle. So if capital B is here, then if you draw a line, it will touch this side. So here will be common B. So this 3.6 will be common B. If this is capital C and we draw a line from it, it will touch this side here. So this 4.2 is common C. And likewise, if you draw a line from capital A, it will touch this side here. So this 5 centimeters is common A. Now we are trying to find angle B here. Therefore, our cosine rule must start with common B so we could end with capital B. So what we're going to have is B squared is equal to A squared plus C squared. And that's because A and C are the other 2 sides. So here you have your B, A and C is the other 2 sides. So we're going to have take away 2AC cosine. Of course, we start with common B, so we're going to end with capital B. Now let's put in our values. So common B is this 3.6. So we're going to have 3.6 squared is equal to A squared, and A is 5, plus C squared, and C is 4.2. So we're going to have that 4.2 squared. Take away 2 times A, which is 5. So 2 times A, which is 5, times C, which is 4.2. Cosine capital B, and we don't know what capital B is. That's what we're trying to find. So I'll go to my scientific calculator and I'll put in 3.6 squared and see what the answer is. Convert that to a decimal. I'll write out this 12.96. So I'll have 12.96 is equal to, I'm going to put this in brackets on the calculator. I'm going to work that out and get the answer. And of course, I'm going to work this out here and get the answer. So I'm going to have 5 squared plus 4.2 squared plus x squared. I'm going to get the answer. Just convert that to a decimal, 42.64. So I'm going to write 42.64, take away. And what I'm going to do is we'll call this 2 times 5 times 4.2. So I'm going to have 2 times 5 times 4.2. Press equal. and I get 42. So what I'm going to have here is 42 cosine B. Now, sometimes students think they can take away this 42.64 from this 42, but these two are not like terms. This come like 42.64, take away 42x. That would cosine B come like the B is a variable, so it's just like an x. I know a term in x can't add or subtract a term in y or even a constant. So they are not like terms, we cannot take them away. So what I have to do is transfer this 42.64 across the equal sign, and the sign in front of it will change from positive to negative. So what I'm going to have is 12.96 take away 42.64 is equal to negative 42 cosine B. So now I'll subtract this on the calculator. So I have 12.96 take away 42.64. I'll get negative 29.68. And that's equal to negative 42 cosine B. So now this negative 42 is being multiplied by the cosine B. So when I transfer it across the equal sign, the operation will change to division. And I'll have negative 29.68 divided by negative 42 is equal to cosine B. Now, we know divided and negative with a negative, the answer is going to be positive. So this is the same as 29.68 over 42 is equal to cosine B. So now, to find angle B, we would have the cos inverse of this 29.68 over 42, and that will give us what angle B is equal to. So we go to our calculator, we press shift and then cosine. So you see the cos inverse comes up, brackets open. So we're going to put that 29.68 divided by 42. And then we're going to close the brackets and press equal. And we see we get 45.035, which is approximately 45. So our answer would be 45 degrees. So we can write that angle ABC is equal to 45 degrees. So now for my first question on the sine rule. Of course, we have a non-right angle triangle. So let's label the triangle first. So if this is capital C, if we draw a line, we'll touch this side. So this will be common C. So AB would be common C. So here we have angle B is 45 degrees. So if we draw a line from angle B, we'll touch this side AC. And this will be common B. And of course, if we draw a line from angle A, which is the 78.7 degrees, it will touch this side here, which is CB, which is 5 centimeters. So side A would be 5 centimeters. So here I want to calculate the length of the side AC. So that means we want to find the missing side AC, and AC is here, which is common B. Now, if you're using the cosine rule, the angle that's given must be in between the two sides that's given. But we have this 45 degrees here, we have 5 centimeters, so that's good. But we don't have the length of the side C here, so we can't use the cosine rule. Look at this 78.7 degrees here. Do we know the length of side B and the length of side C? No. So we don't have a situation where the angle is in between the two given sides. Therefore, we cannot use the cosine rule to find the length of the missing side. And that is why we're going to turn to the sine rule. Now, we want to find the length of the side AC, and that's common B. So to use the sine rule, we'll have to have common B in the sine rule. So we'll have B over sine capital B. And we put this equal to, now, this is going to be an equation here. And we only allowed one unknown. And that unknown is going to be this common B, because that's what we're trying to find. So everything else I use, I must know the length at the side and also the magnitude of the angle. Yes, I know the magnitude of angle B. This is angle B here, 45 degrees. So if I were to use angle C and side C, I don't know the magnitude of angle C nor the length of side C. So I would not say C over sine C. But I know the magnitude of angle A and I know the length of side A. So I'll be using common A over sine angle A. Now, if for some reason I had to use angle C, I could find that easily because the sum of the three interior angles of a triangle must add up to 180 degrees. So I could add up this 78.7 and this 45 and take it away from 180 and I will get angle C. But I still can't use C over sine C if I did that because I still don't know the length of side C. So I'll be using A over sine capital A. And that's because I know the length of side A and also the magnitude of angle A. So I'm going to have B over sine capital B, which is 45 degrees, is equal to, and common A is this 5 centimeters, so 5 centimeters over sine capital A, and capital A is 78.7 degrees. So now I'm going to cross multiply. I'm going to multiply this B by sine 78.7 degrees. So I'm going to have B sine 78.7 degrees. And when I multiply this sine 45 degrees by 5, I'm going to have 5 multiplied by sine 45 degrees. So now this common B, which is what we're going to find, is being multiplied by sine 78.7 degrees. So I'll have to transfer the sine 78.7 degrees across the equal sign, and the operation will change from multiplication to division. So what I'm going to have is B is equal to 5 sine 45 degrees over sine 78.7 degrees. So B is equal to, so I'll bring up my calculator, and for the numerator, I'll open brackets and put 5 sine 45 and close brackets. All right, now see that I open brackets here, and when I press sine, the calculator open brackets. I close this brackets to close off for the 45 degrees and to close brackets again. Right, then divided by sine 78.7 degrees. And I'll close brackets there. Press equal. And we get this 3.6054 and so on. So to three significant figures, we have 1, 2, 3. So after the zeros are 5, so this 0 goes up by 1. So I get 3.61. So B will be 3.61 centimeters. So that means the side AC is equal to 3.61 centimeters. So here I have my second question for my sine rule. So we have a non-right angle triangle, and we want to calculate the magnitude of angle ABC. So that's ABC. So the angle is located at B, the letter in the middle. So that means we find an angle B, so that's why I highlighted here. Now remember the cosine rule. If you were to find a missing angle, you needed the lengths of all three sides. And we don't have that here. We only have the lengths of this side here, BC, and this AC here, which is 3.61. And that is why we're going to turn to the sine rule. So let's label this triangle. So if here's capital B and we draw a line, we'll touch this side. So here's common B. So if here's capital A and we draw a line from this angle, it will touch this side. So here will be common A. And if we draw a line from angle C, we'll touch this line here. So here will be common C. Now, seeing that we want to calculate the magnitude of angle ABC, which is angle B, our sine rule must have angle B in it. So I must have side B over sine angle B. And that'll be equal to, and now seeing that my unknown would be this capital B, because I know what common B is. Common B is 3.61. Whatever I put on this side, I need to know both the length of the side and the angle. So, looking at C, I don't have angle C, and I don't know the length of side C. But I do know the magnitude of angle A and the length of side A. So I'll be using A over sine A. So A over sine A. So let's put in the values. Common B is 3.61. And that's over sine capital B. And capital B is what we want to find. So that's equal to, common A is 5 centimeters. So that's 5 over sine capital A. And capital A is 78.7. So that's 78.7 degrees. So now we'll cross multiply and multiply the sine B by 5. So that'll give us 5 times sine angle B. And then we multiply this 3.61 by sine 78.7. So we'll have 3.61 sine 78.7 degrees. Now, seeing that we want to find the value of capital B, first we'll have to transfer this 5 that's been multiplied by sine B across the equal sign, and the operation will change from multiplication to division. So what we're going to have sine capital B is equal to 3.61 sine 78.7 degrees divided by 5. All right, so I'll have to work all this out on the calculator. So for the numerator, I'll open brackets and put 3.61, then put sine. We're going to have 78.7. I'm going to close brackets because it opened the brackets for the 78.7. And then I need to close brackets because I open brackets for the numerator. So close brackets here, then we're going to divide by 5. So press equal, and we get 0.70800. So I'll write that as 0.708. So I'll have sine angle B is equal to 0.708. And therefore angle B would be equal to the sine inverse of 0.708. So I'll press shift, then sine, and then put in the 0.708, press equal, and we get 45.07, which is approximately 45.1. So we have angle B is equal to 45.1 degrees. So therefore, angle ABC is equal to 45.1 degrees. And that would bring us to the end of this video.